Hello guys, welcome back to Maison African Motives. Still on A-level mathematics, we have a question that we are going to focus on our vector 2 revision. From one of the question papers, we are given the equation that is of a straight line, in this case in vector form. So we are given that the line is equation R is equal to, okay, so this is the equation of the line that you are given in this case. And also we are given, and the plane P has the equation which is R dot the modulus that we are given, which is equal to 1 in this case. So these are the two equations that we have, the one of a line and the one of a plane, which is P. So the question on A is to find the coordinates of the point A where L intersects P, which means where L, which is the line, intersects P. Our P is the plane. So we need the point of intersection of a line and a plane, of which we understand that if we are given a point of intersection, we are saying where these two meets, where these two they are going to meet at a certain point. So where that at that point where the two meet, we are going to say refer to this point as our A. So we need the coordinates of this point A. But how is that possible? Just like a normal function and a straight line, or a normal quadratic function and a straight line, where we are referring to the point of intersection, we are saying at this point of intersection, or at these points of intersection that we have, we are having same values at the point of intersection for both curves, the straight line and the normal function. So it is the same concept with a vector to say, if we are given a line and a plane, at a point of intersection, these two, they will be equal. These are that we are having, and these are, they will be equal. So if these two, they are equal, what we are going to simply refer to, or what we are going to do, is to find R from a straight line as a single vector, or as a single point in this case. So that means our R in this case is going to give us, okay, let's just try to reduce this. Let's try to reduce a little bit. So it means our R in this case, we are going to add, all right, so that we can equate these two. All right, so that means our R, by multiplying by the lambda that we have, multiply to -1, we are going to have 0, 4, 7. So that's plus times a minus, which is a minus. So that's lambda times -1, which is negative lambda. Then positive and positive, this is going to be positive 2 lambda, plus also this one is the same thing. So this is what you're going to obtain in terms of a single term. So now it means if I can substitute this R that I'm having from the line, I can substitute in place of R, because these two, they are equal. So I can take that as an advantage to replace this R that I'm having in place of R, and I can perform the dot product that we are given. In this case, take note, we are given that R dot 2, 4, 3 should give us a positive 1. So it means I can substitute the R that I calculated from what? From the straight line. So this is going to give us 0 minus lambda. We have got 4 plus 2 lambda. In this case, we've got 7 plus 2 lambda in this case. So this whole part that we have, we apply our dot product to 2, 4, 3. So this is going to help us to calculate the value for lambda. And by having this value of lambda, what are you going to do? We are just going to substitute in place of R, so that we have the point which we are referring to as A. So this is the idea, or the concept on how to answer these typical questions. All right, so let's multiply. So the dot product, we are multiplying corresponding terms, all right? Corresponding terms, we add, corresponding terms, we add. So that's 2 times 0 here, which is a 0, 2 times minus lambda, which is minus 2 lambda in this case. So 4 is going to multiply this whole part of 4 plus 2 lambda. This part we multiply by 4. So this is going to be plus, that's 4 times 4, which is 16. 4 times 2, which is plus 8 lambda in this case. We do the same thing on 3. So it's 3 and 7. So this is going to be plus 21, 3, and 2, which is going to give us 6 lambda, which is equal to 1. So by having this equation alone, it can help us to have or to determine the value of lambda, because now we are having a normal equation that we are used to. So we can simplify, collect the terms with lambda. In this case, that's minus 2 plus 6 plus 8 plus 6. So if we add this part, this is going to give us positive 12. So that's positive 12 lambda. We move on to constants. That's 6 plus 21 in this case, which is going to give us 37. So we've got plus 37, which is going to give us negative positive 1. Why am I having a negative here? So this is a positive 1. So if we are to transpose, that's 12 lambda is equivalent to, if we transpose this to the right-hand side, this can be a negative 37. So 1 minus 37, which is negative 36. So divide by 12 both sides so that you can obtain the exact value of lambda in this case, which is going to give us negative 3. So like I said, at the point of intersection, these two, they are equal. The line and the plane, at that point, the value of A that lies on the plane, which is the point A, is the same. So we are going to substitute where we have simplified on a straight line. We simplify that R is equivalent to this expression here. So if we are to substitute that value of lambda that we obtained, remember, we got that our lambda in this case is negative 3. So we can substitute, or let me just write it here so that I avoid this issue of mixing a lot of things. So let's just have our final part here. So remember previously that we expressed our R in this case as 0 minus lambda. And this is 4 plus 2 lambda in this case. And the other one was 7. 7 plus 2 lambda and so on. So this is what we're given. So we can substitute this to obtain the value of A, which is at a point where our lambda is negative 3. So if we are to substitute here, this is going to be a negative 3, a negative 3 here, a negative. In place of lambda, you're substituting negative 3. 0 minus minus 3, that's a positive. 4 plus 2 minus 3, 2 times minus 3, that's negative 6. So this is going to give us negative 2. And if you simplify, 7 times 7 plus 2 times negative 3, which is a positive 1, that's 7 minus 6, which is going to give us a positive 1 in this case. So that's our R in this case, representing the point A, which is the point that is representing the point of intersection. It's at point A. So this is our A. So you can write this in coordinate form. So therefore, our point A can be written as 3, negative 2, positive 1 like this. So this is going to represent the point A, which is the point that we are having at the intersection of the line and the plane. So we shall have other questions where we are going to have intersection of two straight lines, of two lines, intersection of two planes, and so forth. So it depends with the question that you're given, but in this case, a plane and a line. Then on the other part, we are now given that the point B is coordinates 0, 4, 7. Calculate the angle between the line AB and P, which is P is representing the plane P. If you take note here, P is our plane. This is the plane. So we are given that we are supposed to calculate the acute angle between the line AB and the plane P. All right. I want you to check something here. Remember, we are given before. So this is our B item 1. We are given before, or we calculated before, the point A, which means if you got this point wrong, it is going to affect everything. For you to obtain AB, you need the point A. So this point is needed, which is 3 minus 2, 1. So we have our point A, that's 3, negative 2, 1 in this case. And the point B, we are given now that B is 0, 4, 7 in this case. So if we are to take note, from these points, we can determine AB, which is the one that we are given. Then P is the plane that we are given, and we are given this plane P as this part here, which is r dot whatever that you're given to. Let me just write it here. So this is r dot that was 2. All right, let me 243. Yeah, that was 243, which is equivalent to 1. So if we are to consider an angle, which is the acute angle, what is the formula? Take note, if we are dealing with the plane and a line, the angle is going to be referred to as cos 90 degrees minus theta. This is the angle that you're going to remember. In our actual sense, the angle that is between, if you are referring to an angle between two vectors, we are just referring to two lines. We know that we are supposed to use this as the cos of theta is equal to the dot product over the moduli product. But in this case, the angle is not going to be directly the theta, this one that we are having. We are referring to the angle that is in between, which is 90 minus theta. So it's going to be 90 degrees minus theta if between a plane and a line, or a line and a plane. But this 90 minus theta is equivalent, the cos of 90 minus theta is equivalent to the sine of theta from our trick. So this can be very, very important for you to understand that the cos of 90 minus theta is equal to sine theta, which is equal to the dot product. So this is equivalent to the dot product over the moduli product. So there's dot product over the moduli product. All right, so this is the concept that you're going to apply for finding an angle between a line and a plane. You use sine theta. So we are going to refer from sine theta. So the dot product that we are referring to in this case is the dot product of the line AB. Take note, it's line AB. So we are going to take the dot product of AB to the plane, which is this part that represents our n. So which means our formula can be referred to as sine of theta is equivalent to. So the dot product, according to this question, we are referring to AB dot this part of the plane, which is our n, which we are given, and the moduli product, that means we are going to obtain the moduli of vector AB. So let's just write this in the vector form, times the moduli of the same n, which is the normal part that we are given. In this case, we're going to find this moduli, or the modulus of this part, which is our n in this case. So from this formula, we can determine the acute angle, which is our theta. So what does it mean? We are going to refer back to the points A and B to determine the vector AB, because we have this n from the plane, but AB we do not have. We are supposed to calculate it from the points that we are given. So remember that from 2 points, we can determine the vector of AB, which is OB minus OA. That's the last minus the first. So it's OB minus OA, which is our OB in vector form. That's 0, 4, 7 minus OA, which is 3, -2, 1. So we can simplify this 0 minus 3 corresponding terms. That's 0 minus 3, which is -3, 4 minus -2, that's a +6. 7 minus 1, which is a +6 again. So this is going to represent our vector AB. So we have vector AB, and like I said, our n is already there from our plane. This is representing our n, which is 2, 4, 3. So we are just going to apply A, B, and N on this formula that we are given. So that means in this case, the sine of theta is going to give us the dot product of AB, which is vector AB, that's -3, 6, 6 to the product of what? N, and our N is 2, 4, 3, which is 2, 4, 3, this part that you're given. So that's 2, 4, 3 in this case. All right. So that means in this case, we can find the moduli, or I mean the modulus of vector AB. We have our vector AB. So remember that the modulus of a vector, if our vector is ABC, then the modulus of that vector AB given as ABC is going to be the square root of A squared plus B squared plus C squared. That is the modulus of a certain vector that you be given. So in this case, this is your A, this is your B, this is your C. So we are going to have the square root of -3 squared plus, this is going to give us 6 squared plus 6 squared, which is our C squared, times, this is a product, the moduli product. You are multiplying to the modulus of the n, which is the n that we get from our normal, which is 2, 4, 3. Just like A squared, B squared, C squared, this is going to give us 2 squared plus 4 squared and 3 squared. So this is what you're going to have in this case as the moduli product of the two. So if we are to simplify further, in this case, we are going to obtain the sine of theta that is equal to, you perform your dot product. How do we perform this? How are we going to perform it? We are multiplying corresponding terms, adding, like I think we talked about this before. So it's -3 versus 2. So you multiply this together, which is -6 plus 6 times 4, which is +24, 6 and 3, which is a +18. Everything over the modulus of this first part. If you simplify, this is going to give you a 9 times the square root of 29. If we simplify everything, this is going to give us 29 in this case. So in order for us to determine the sine of theta, we can simplify further the numerator. That means our sine of theta is going to give us 36 over 9, of which you can reduce 36 and 9, which is 4, or you can even leave it like that. If you reduce this one, is same as 4 here. So that means the sine of theta is equal to 4 over the square root of 29. So how can we determine the theta? So remember that theta is equivalent to the arc sine. Okay, sorry for that. That is the arc sine of 4 over the square root of 29. So this is what you're going to have. So this gives us directly the acute angle, since the trig that we are given is a positive, and sine being the ratio here being a positive is going to be exactly an acute angle. So that means the arc sine of this value is going to give us 47, that was 47, 9688 and so forth. So if you had to round off to one decimal place, this is an angle. So to one decimal place, that 6 is going to change the 9 into 10, gives us 1 here, which is 8. So we are going to have 48, 0 degrees. Okay, so that's a 0 here. So that's theta. Our acute angle is 48,0 degrees. That's to one decimal place, depending with the degree of accuracy that you're given on the question paper that you are having on your finals. Okay, so this is how you determine an acute angle between a line, take note, and a plane. So from the points that you are given, you can determine the vector. Since the formula needs the vector, that is the dot product that you're going to involve in your calculation, we need this vector AB. All right, so that was the consideration of the question. We had calculated the point A, and we are given the point B. So we can calculate our vector AB. All right, so that was our question on B item 1. So let's move on to B item 2, which is carrying 5 marks in this case on determining the perpendicular distance from B to P. B, what is B representing? That is what you are supposed to be very, very careful with. B, it's a point. We are referring to B as a point, and the P is representing the plane. From this part here, P is the plane. So the question is asking us in this case to determine the perpendicular distance from a point to a plane. So how do you determine the perpendicular distance from a certain point to a plane? So I'm just going to have a simpler sketch. Let's say I've got our plane represented from a certain point in this manner. we have got 90 degrees that you're going to have here. So this is our point B, which is given. Remember, B, we are given that's 047, the point B already. We have this point B here. The point B has coordinates. The point B is not going to change. So B, it's a point, but it's taken to the plane P, which is the one that we were given before. Remember that the plane was given as R dot, so that was R dot 2, 4, 3, which is equal to 1. Okay, so I want you to understand this concept because questions they are going to repeat on determining the perpendicular distance. Okay, if you can have your point B, let's say we have got our point, which is from the point given as x, y, z. Let's say this is x, y, z like this. That's our point B. And we are given the plane as r dot, then we can write this as A, B, C is equal to D. Let's say this is the format that we are given for the plane. Okay, the distance that you are going to take between this point B given as XYZ and the plane given as R dot A, B, C in this format is going to be given by the modulus of, take note, AX plus BY. You multiply A to X, B to Y. So this is going to be BY plus C to Z. Then the D as it is on this side, we are going to subtract that D. Take note, if our D, if our format, the format is the one that is important. If you are having it in this format, then your formula is going to carry a negative because you might see another formula carrying a positive. It's because of the format that you are given. All right. So according to this format, this is going to carry a negative. All right. Everything over, okay, let me just redo this. So it's going to be everything over the square root of, which is the moduli of the plane, which is a squared plus b squared plus c squared. So we need the moduli, the modulus of this. So that is how you simplify the perpendicular distance from a point. So meaning to say, we can take our B using this same format that you are given. Remember, our B is supposed to be XYZ. So this is our B, which is XYZ. So we are going to take our point B, that's 047. So remember that our point B was 047. So this is your XYZ. Okay, that's our XYZ in this concept. Then our plane was given as R dot, that is 243. So this was 243, which is equal to 1. So it means the perpendicular distance now, which is the D, is going to be given as AX. That is A times X. 2 times a 0. So that's 2 times a 0 in this case. Okay, so we are going to have 2 by a 0 plus BY, that's B, which is A, B, C. So B is 4. That's 4 times Y, 4 times 4. So this is going to be 4 times 4. Then CZ, that's C times Z, 3 times 7. So plus 3 times 7 minus D, which is this one. So minus 1, everything over the modulus concept, which is a squared plus b squared plus c squared, that's ABC. So it is going to be the square root of 2 squared, which is our A, our B, which is 4 squared, our C, which is 3 squared. So you need to determine the modulus that is a positive answer only is the one that is we need. So that's how you determine the perpendicular distance. So simplifying from the numerator or just everything at once, let's simplify everything just everything, guys. This is going to give us 36 square root of 29 over 29. Guys, also the calculators that you are using for A level must be advanced calculators, such as the Casio and so forth. The right view, yes, those ones, they can simplify these fractions, not to work with the DAL, guys. That one, yes, there is another DAL which is advanced one, not the one that That one for all that we're using for all level, guys. No, no, no. We are supposed to use an advanced calculator for our calculations. We will enjoy this A-level syllabus if you're having a nice calculator. All right. So that's what you're going to have in this case, or you can even write this as a decimal. So you can write as a decimal, which is 6,685,032, something like that, 032. So if you are to round off to 3 significant figures, because this is not an angle, so you can write to 3SF, 1, 2, 3, that is going to be 6,69. This can change to 9 units. So that is what you're going to have in this case. So if you are dealing with the distance, that is the perpendicular distance from a point to a plane, one, you need the formula based from the format that you are given, especially on the plane, because it is the one that most affects us on its format. So if you have your format in this form, then you are going to subtract a D. If you write it in a Cartesian form, depending with where your D is, then adjust on your formula on this plus or on this minus to be a plus if your D is on the left hand side. But if your D is on this side, then it is going to be a minus D on the formula. Okay, so that is how we can simplify the perpendicular distance from a certain point to a plane. So this was vector 2 from past exam papers. So guys, let's revise as much as we can. These are the typical questions that they can ask in our final exams. All you need to understand is the concept of each part. A plane to a plane, a line to a plane, a line to a line, a point to a line, a point to a plane. Just that basic understanding on vector 2 can help you to answer any question, because everything is just a repetition. If you check your past exam papers, you see it's just a repetition. So that's it for now. From Amazon African Motives, till we meet again.